Hello everyone, my name is Mohamed. I am a Java developer. This video is about another Java library I've been working on this past few weeks. But before I jump into the code and show you what the library does, I'm gonna quickly talk about two different concepts, which are actually the base concepts of the library itself. So the first one is known as the ISP. It's the interface segregation principle. According to that principle, no code should be forced to depend on methods it doesn't use. And following that, we should split large interfaces into small and specific ones so that clients will only have to know about the methods that are of interest to them. Trying to illustrate that principle with an example we have here. This is based on a typical day-to-day life situation. So let's say as a person, you want to socialize. So if you implement the large interface we have here, which we call sociable, you will have to implement every single one of these abstract methods that you see defined here, which is actually what the ISP is advising against. Instead, ISP recommends to split the large interface into smaller ones like these ones you see here, these three right here. And as you can see now, if the person is a student, for example, and not a worker, he will only have to implement the student sociable subinterface created right there. And that will force him to only have to implement these two methods right here, additionally to, of course, the base method, which it's inherit from the parent interface, which was the large one and now became so small, as you can see, has only one method, which is common to all the created sub interfaces. As you can see, apart from student, we also have the case of worker sociable and active worker sociable, which have their respective methods that have nothing to do with the student methods. So that's basically what the ISP is about. Now, apart from the ISP, there is also a recently introduced feature in Java 17 named the sealed classes and interfaces, finalized as the enhancement proposal 409. And what this mainly allows is to have more detailed control over inheritance, and mainly by allowing classes and interfaces to define their permitted subtypes. Okay, when we talk about permitted subtypes here, it's some sort of permission list which is maintained by the sealed interface or sealed class, and where they clearly define which subclasses or sub-interfaces can implement or extend them. So if we go back to the segregated interfaces we have here, what used to happen before Java 17 was that all of these interfaces or sub-interfaces you are looking at right here will all be publicly and widely accessible and extensible from any other class, interface, anywhere in the code, without control, without any restriction of any kind. But now, with the concept of sealed interfaces, we can define those interfaces so that no existing class or interface will implement or extend them without previously requesting permission to be added to the permission list maintained by the sealed interface. So that's basically what the concept of sealed interface and class is about in Java 17. Now, going back to the library, which is the main subject of this video, what the library is gonna be doing here is gonna take you from here, from the definition of your large interface, which can have as many methods as possible. You can have 100 if you want, And the library provides an annotation that will allow you to specify which methods of the large interface will go to which profile. Now, the concept of profile is proper to the library, not to Java, not to any other principle. Once I show you how to use the library in the code, you will understand what we call a profile. Now, once you specify which methods go where and run your project compilation, that's when all the smaller interfaces, the one here, they will be all generated as sealed interfaces, which means each one of them will maintain its respective permission list. Okay, and our library will also allow you to update that permission list by using an additional annotation. We will see that in the code shortly, and even allow you to generate a report so that you can the report that's generated is going to allow you to know exactly which classes or interfaces from your code is implementing or extending which one of the sealed interfaces that were generated by the library. All right, let's look at all that in the code. So this is a simple project with our sociable interface, as you can see it right here, with every abstract method defined here. And well, the library is added to our project through a Maven dependency here, as we do with any other library. And as I mentioned, some annotations will be provided by the library so that you can use them to specify which methods go to which profiles. So if we take a look once again at our UML diagram here, as we can see here, we have the start conversation method, which is actually common to all of the sub interfaces you see here. So that will mean that here our start conversation has to be sealed or tagged for all of the profiles. So let's do this using one of the annotations. We have the annotation sealed for profile provided by our library, which is then go to profile student, and the same annotation can be repeated in case you want to let's say associate one method to more than one profile. So here the other profile is worker and the third one is active worker. If you want, you can use the plural form of the sealed for profile annotation. You know, this one over here, as you see can take only one single value, string value, but if you make it the plural form, you can also specify an array of yeah, like this. You're gonna move them all there from here, and this one also goes here. So here you will have we can then remove these, and we can make it even more interesting by creating a constant which we're gonna reuse for the other methods right here. Now, if we move to the student sub interface, as we can see, apart from the start conversation, the student sub interface or profile, in the case of the library, will also have access to attend class and ask for help when needed. So we're gonna tag those two only for students. So in that case, we will use only this annotation, and that's it. Same thing here, ask for help when needed. Now, same thing for worker and active worker. As you can see, worker and active worker also have access to the same start conversation based method. That one is common to all, and additionally to that, he also has access to join office social groups. So we do sealed for profile here, we enter worker, and the active worker as you can see, is extending from worker, which in turn extend from sociable. So that means active worker actually has access to every single one of these methods we see here. 1, 2, 3, 4, these 4. So we're gonna have to tag those. As we can see here, we have specifically to active worker first, we have this, and that we're just gonna copy paste. And additionally to that, it also shares the same method as the worker, which is join office social group. So this is basically what using our library looks like. It's gonna look like when you would like to create sub interfaces, or specifically sealed sub interfaces in this case, based on profiles which you define yourself and then specify them using the annotation provided by the library. So once you do this, basically your work is done here. You just have to run the compilation of your project. So I'm gonna do a compile here, and let's check what it outputs here. Okay, here you have a little bit of output here telling you that a few files have been generated. So you have the sealed active worker sociable, sealed worker sociable, sealed student, sealed, and a few additional files which we're gonna explain exactly why they are here and what they really do. Now, if we go to the output folder where we have the generated sources, we have all the files there. As we can see, if we refer to our diagram, the sealed sociable interface has only one method, which is the start conversation, which corresponds really well to what has been generated here in the code. So as you can see, we have start conversation returning a string and throwing any legal state exception. And as we mentioned, regarding the sealed interfaces and classes, each one of them maintains a permits list which specify which sub-interfaces or subclasses is extending or implementing them, which is the case here. As you can see, if we go back to the diagram, the sociable class, the generated sociable class sub-interface will permit worker sociable and student sociable to extend it. So that's why you see the permit list here having the corresponding two sub-interfaces, sealed sub-interfaces here for the sealed sociable one. All right. So if we move on to the sealed student sociable sealed interface, as you can see, it extends the sealed sociable one, which was generated also. And of course, we have the two methods which are corresponding to what they are supposed to, what the sealed student is supposed to implement. And something interesting here, which we added ourselves in the library, is for every, let me go back quickly to the diagram again. For every interface which is like at the lowest level of the diagram, the hierarchy, as you look at it right here, the entire thing, because we don't have any subclass or subinterface defined by default, like we had with the sociable one, which was generated right now. Because of that, according to the concept of sealed interfaces and sealed classes, the code actually wouldn't compile if you have an empty, you have the definition of a sealed interface without a permits section here. So to avoid that, we additionally to generating all the sealed sub-interfaces that we need in order to achieve the segregation principle here, we will also generate a final class which will carry the name of the large interface, in this case sociable. It will be sociable followed with the name, the suffix final class. And if you look at the content of this final class, what it really does is it implements, as I just mentioned now, the interfaces that are at the lowest level, because those don't have any child interface or child class defined by default yet. So it will implement all of those. In this case, we have two, which is the student and the active worker, and it will also generate default implementations for all of the methods that we find in the large interface. Each one of those implementations will only return default values. So this is a class you definitely won't find useful in any ways. So it's generated only for pure convenience, we will see, just to avoid compile errors, and that's it. So we just went through the student sociable sealed class, and then you have the sealed worker, which extend sealed sociable and permit the sealed active worker sociable, as we saw in the hierarchy. And now the sealed active worker sociable, just like the sealed student, which is at the lowest level, will also permit the generated final class, so that we will avoid compiled errors. And of course, you have the method from the mapping of the SIL4 profile, which are generated here. So that's basically it. As you can see, we generated all the sealed sub-interfaces, and by doing that, we achieved the ISP along with the concept of sealed classes and interfaces. And additionally to that, as I mentioned in the presentation, we have this report, which is a very simple text report. It will only list, for each one of the large interfaces that you define and tagged with our SIL4 profile annotations, it will list you the created SIL interface, and for each one of those, it will list you the children classes or interfaces. So that will give you like a report, which will allow you to know exactly which element or component of your code is extending or implementing which one of the generated sealed classes. And now, interestingly, you will see that we will be able to create a new class and choose to implement either one of these sealed interfaces. And once we run our compilation, the report will be updated to reflect that class here. All right, let's just show it. So let's say we want to create a class. Let's name it student, worker, hybrid. Okay. So we are dealing here with a class which wants to implement both the sealed student sociable and sealed worker sociable. Alright, before we continue from here, one of the rules of the sealed interfaces and classes in Java is that for a class to implement any sealed interface, it has to be either final, sealed, or non-sealed. So here, let's just make it final. Now, as you can see, we still have compile errors. Let's just see what it is. Here, what it says is that we have to implement all the abstract method from both interfaces we are implementing, which is a typical known rule. So let's do this with the IDE here by clicking implement method. As you can see, we have method from both the two sealed interfaces and also from the parent interface. So we consider this being implementations. And despite this, we still have compilation errors, and these ones this time are referring to the fact that the permit lists of sealed student sociable and sealed worker sociable do not have this class we are creating here in them. So if you look at this here, you can see sealed student sociable permits only the generated final class, while the other one, the sealed worker sociable, permits the sealed active worker sociable, which is a sub-interface extended from it. So obviously, as we don't have our class in that permit list, both are failing. You can add those permit lists manually, but remember that these classes, sealed interfaces are all generated. So whenever you run your compilation, they will be regenerated and your changes will be lost. So that's the reason why we had to provide an additional annotation in our library, which you will use to update those permit lists. And how to use that is by calling it here add to profile. Now, this one works differently from the previous one. With this one, you are required to provide always to provide two attributes, which is profile name and interface name. The profile name will be corresponding to the profile. So in this case, let's say student, and the interface name here has to be the fully qualified name of the interface. So better just copy it from here, copy reference and add it here. For now, we are allowing only the fully qualified name for the interface name. If not, it won't be working, because actually the library allows you to segregate more than just one large interface. In this case, we have only one, so it looks simple, but it can be more than one, in which case you will need the fully qualified name to identify the interface with a unique name. So apart from student, we also have to do the same for worker. So we'll just copy paste and change this to worker. I can actually just use the same constant we defined from the sociable yeah, the sociable interface. So that will just keep the code a bit cleaner. Yeah, and here we go. So now we added both profiles to our class definition, we can say, through this annotation, only to tell our library that this class should be added to the permit list of each one of the sealed interfaces it's trying to implement here. So all we have to do now, as you can see, we still have compilation error. So all we have to do now is to run another compilation here, same as we did, maven clean compile, and let's see what happened. Alright, we have a build success. The files were all generated along with the report and the final class. And now, as you can see, if we go back to the editor, the compilation errors are gone. And why they are gone is because when you look now at the generated sealed student interface, we now have an updated permit list which contains the class that we just created. Same thing with the sealed worker sociable, which also now contains, well, it used to contain the sealed active worker sociable sub interface already. Now we added to that the new class that we just created. And if you look at the report itself, yeah, the report also has been updated by adding the class name here, the fully qualified name of the class, as you can see. So it's more precise for with classes. You have the fully qualified names, so you know exactly which class is being is implementing this, and same thing here. All right, so that's why it is. So that's how the our library works, by providing these two annotations: seed for profile and add to profile. And well, this is a work in progress. We're still working on it, and any idea you guys have, any suggestion, just let us know. And it's we hope to finish this soon and release it to the public, just like the previous library also. And that's it. If anything else, just leave comments, and thank you for watching. Bye.